Hi, I'm Alan. Today, let's talk about a different approach to solve the growing annuity problem. In fact, we can solve the growing annuity with the difference of the two growing perpetuity. Let's look at this example. Sarah just won a lottery that pays her $10,000 per year for the next 20 years, beginning in the end of the first year. The payments are expected to increase by 3% each year to account for inflation. If the discount rate is 5%, what is the present value of the growing annuity? Well, to solve this question, first we need to draw the timeline. So we just draw the timeline here, and we got to indicate the years. So this is the 0, and this is 1, and this is 2, and this is 3, and this is 4, and then so on until you got the 20 years. The first year, you are going to receive $10,000, and second year, you're going to get 10,000 multiplied by 1.03, and then the third year you got 10,000 multiplied by 1.03 to the power of 2 until you got 10,000 multiplied by 1.03 to the power of 19. So normally to solve this question, we can just use the following formula. Is the present value equals to the cash flow divided by the R minus G multiplied by 1 minus 1 plus G divided by 1 plus R to the power of N, close bracket. So putting in the number is just 10,000 divided by 5% minus 3%. Multiplied by 1 minus 1.03 divided by 1.05 to the power of 20, because we got 20 years and 20 payments. So the answer is going to be equal to $159,647.84. That is the traditional way to do it. Another way to do it is to finding difference of the two perpetuity. So first we can just delete this, and then we can add one more year. So the last year is 21, and that would be $10,000 multiplied by 1.03 to the power of 20. The purpose of adding this cash flow is to find the present value of the perpetuity of PB2 starting from year 21 until forever. So we have the PB1 here at this point in time from year 1 to year infinity. The value for PB1 is equals to $10,000 divided by 5% minus 3%. Well, you can check it with using your calculator. The number I got would be $500,000. The next step to do is to find the PB2, which is equals to the cash flow of year 21 divided by the 5% minus the 3%. So from the timeline, you see that the cash flow would be $10,000 multiplied by 1.03 to the power of 20 divided by 5% minus 3%. The answer should be equal to $903,055.62. By the way, you cannot directly subtract the two present value because they are the two number at different point in time. Therefore, we need to discount this PB2 back to time 0 in order to find the difference. To get the present value of this growing annuity, it is equals to $500,000 subtract the PB2, which is 903,055.62 divided by 1.05 to the power of 20. You can check the answer with your calculator. The answer I got would be $159,647.84. Notice that the answer is exactly the same as the answer we just calculated with the long formula. Well, this is a less calculation involved and it's simpler. That's it for today. Thank you.